The effects of climate change are becoming more apparent, so much that coral reefs across the globe are in danger. Studies show that estimated levels of carbon dioxide and increases in temperature over the upcoming years surpass conditions of which coral reefs are able to survive. Not all species have shown adaptation, so efforts to reduce the progression of global warming must be implemented immediately. Corals can be found all across the ocean, but reef-building corals mainly dominate shallow and subtropical waters because of the amount of sunlight they require and the warmer temperatures they prefer, which is between 70 degrees and 85 degrees Fahrenheit. Millions of years of evolution have helped reefs adapt to yearly disturbances. However, recent increases of average temperatures in marine environments have proved that the adaptive capacity of coral reefs cannot keep up. These changes cause bleaching events and disease. Another concern is atmospheric carbon dioxide absorption into the ocean. High levels of CO2 can alter the ocean's natural chemistry by making it more acidic. In addition, rising ocean temperatures are rapidly wiping out entire reef communities, which are then being replaced by seaweeds. Such shifts have already taken place in parts of the Caribbean where entire communities have been wiped out by chronic disease. Human populations attribute negative effects on corals as well. Because coral reefs are largely located along coastal regions, they regularly come into contact with humans. Human-induced factors such as overharvesting, reduced water quality, and overfishing have detrimental effects on reefs and can only exacerbate the effects of climate change. By allowing the destruction of coral reefs, we are losing a natural resource. Corals provide communities with economic benefits such as fisheries and tourism, and invaluable aids like storm buffers. To restrict the amount of damage to coral reefs, best management practices through no-take zones or NTAs need to be put forth. NTAs are areas set aside by the government to prohibit many extractive activities. Along with NTAs, larger scale improvements will lead to a better understanding of coral reef systems. Most of the research that has been done on coral reefs is smaller scale and short term, so it does not provide much insight into future trends. Another area of research that needs expanding is the genetic dissection of resilient species, or looking into the traits that allow for adaptation to climate change. Doing so could lead to the discovery of mortality from bleaching. Most importantly, all of these aspects of resilience must be applied on local, regional, and global levels. Elimination of local stressors is also crucial. Coastal pollution can be caused by agricultural runoff into watersheds. Overfishing harms the ecosystem by eliminating some reef fishes and invertebrates, altering the food web dynamic. Through a variety of mitigation strategies, like the implementation of public policies on land use practices, these issues can be resolved. Climate change and humans have already led to damage and loss, but there are some that are able to adapt. Further research of coral reefs can provide scientists with more information into adaptation and recovery methods. The construction of more marine reserves can help already damaged corals in the recovery process and protect those that are still healthy. Public policy will play a large role in the alleviation of human-induced stressors. Maintaining coral reef sustainability will be difficult, however, with enough effort, it is possible to save this species.